Good day to you, dear panelists. We'll be presenting our thesis topic, Design and Fabrication of Automated Scotch Yoke Potato Matchstick Cutting Machine. Now, these are the researchers that are involved, and our research advisor, Professor Camilo Jose S. Sabanya III. And our research timeline for producing the chapter 1 up to the chapter 5. Now, French fries are one of the favorite foods that everyone crave to eat. The demand of this potato product is very high, especially in fast food chains. As a result, entrepreneurs have designed a semi-automatic potato slicer for fast production. But the continuous demand in the market requires a more efficient processing machine. Production of potato matchstick using a semi-automatic cutting machine is still taxing for the laborers as it still involves human factors in order to produce the potato matchsticks. This problem has led to less production of potato matchsticks. Low production rate of product is a problem as it creates low gains for the producers. The aim of this research is to design a motor-driven machine that cuts potatoes into matchsticks, which further reduces the human effort. The machine has a Scotch Yoke mechanism which operates through a motor. The machine is expected to be more productive than a semi-automatic potato cutting machine.
Statement of the problem. In producing potato matchstick, most producers use a semi-automatic potato cutting machine to lessen the burden of the workers from using manual slicing machine, which is laborious and causes low production rate. However, using the semi-automatic potato cutting machine still involves human effort in doing many tasks and still leads to low productivity. Hence, the researchers will fabricate a machine that will reduce the inconvenience of the worker and improve the productivity of the machine in producing potato matchstick. Objectives of the study. The study major goals is to develop an automated Scotch Yoke potato matchstick cutting machine, and the following are the study's particular goals are to design an automated potato matchstick cutting machine using the Scotch Yoke mechanism, and to evaluate the effectiveness of the automated Scotch Yoke potato matchstick cutting machine.
Conceptual framework. It shows the conceptual process to attain the desired output. The input of the given framework is the baseline research, components identification, and data gatherings. Furthermore, the process of the framework involves the designing of the control system and circuit, implementation, and assembling. Meanwhile, the output has complete prototype, test, and evaluation.
Scope and limitation. The shape of the potato will be treated as irregular with an approximate thickness width of 3 inches and length that is limited from 3 inches to 3.5 inches. The evaluation will be determined by its capacity in terms of kilogram per hour of potato matchsticks that will be produced. Major components of the machine include a single phase induction motor, speed reducer, chain and sprockets, Scotch Yoke body parts consisting of 2 connecting rods, 2 post blocks, foundation and supports, and a circular disc with a cam follower connected to the cam which dwells at both sides, grid blades, feeding assembly, metallic sheet, and a frame. Definition of terms. Automation. A wide range of technology in which human effort is reduced. HP. A unit of measurement of power or the rate at which work is done, usually in reference to the output of engines or motors. Mechatronics. A branch of engineering that focuses on designing, manufacturing, and maintaining products that have both mechanical and electronic components. Relay. An electrically operated or electromechanical switch composed of an electromagnet, an armature, a spring, and a set of electrical contacts. Sensor. A device that measures physical input from its environment and converts it into a data that can be interpreted by either a human or a machine.
For our topic, we have gathered 5 published works of literature for our related studies. Now, Fleiss and his companions designed a semi-automatic French fries cutter, which is much cheaper. The cutter from the motor is designed by implementing the concept of crank rotation with a pusher to push the potato to the cutting blade. A potato peeler is located on top of the machine and rotated by an AC electric motor. An automatic machine was fabricated by Gokul and his companions in 2020. The machine has a slider crank mechanism which presses the vegetables against the blade, in which motor's rotary motion is converted into linear reciprocating motion of the piston. A design of automatic potato slicing machine which was done by Lat and Tho, where slicing wheel is mounted on the shaft rotating by an electric motor with a power of 1.1 kilowatts. During their testing, they were able to produce 4.3 kg per minute of potato slices in just 5 seconds. The recorded efficiency of the machine was over 88%. As for Kingsley Omoyibo, he designed a potato slicing machine with a 5 horsepower motor at the Igbinedion University Okada. The machine he designed was able to produce damage efficiency of 4.8%, while the slicing efficiency 95.18%. As our design uses the Scotch Yoke mechanism, we included Al Hamad and his companions' research in Scotch Yoke mechanism. The Scotch Yoke converts the rotational motion into reciprocating motion, or vice versa. The major advantage of the Scotch Yoke is the absence of the transverse force, which contributes to large piston assembly, secondary motion in slider crank mechanism, which ensuing frictional loss, induced noise, and wear in the machine parts.
Methodology. The purpose of this study is to present underlying effective methods to be used as a means and aid for the success of the study, as well as the procedures and techniques that underpins the realization of the study's objectives. The methodological framework is the section of the study wherein it shows the steps that the researchers have to follow the process. So first process is the design. Identifying the components, find a design fabricating team, components of the research such as electric motor and speed reducer. For the development process, developing of the design, prototype assembling, and the implementation. So for testing and troubleshooting, testing of the control and power circuit, and troubleshooting. For the last process, which is the evaluation, evaluating the output of the prototype.
Design. These are the components of the concept design: the feed chute, the feed selector, the frame, the blade, induction motor, chains, sprocket, switch, proximity sensor, speed reducer, selector, scotch, yoke, and piston. So when the potatoes were put in the feed chute down to the feed selector, then when the proximity sensor sends the potato, the electric motor will on and the potatoes will go to the blades and cut into a matchsticks. So these are the front view, the right view, the side view, and the isometric view.
Design and components. Induction motor. The component is responsible for the movement of the Scotch Yoke mechanism. Scotch Yoke. The mechanism for processing of the potato is the Scotch Yoke mechanism. Through the rotation of the motor being delivered of the yoke, both Scotch alternately press the potatoes into the blades into both sides, which then reduce the potato into matchsticks. Speed reducer reduces the speed of the motor for a quality of cut of potato matchsticks. Chain and sprocket deliver the rotational power of the motor into the Scotch Yoke. Capacitive proximity sensor serves as a switch where the motor will only run if the sensor detects the presence of the potato.
Development. Through the rotation caused by the electric motor, the Scotch yoke alternately moves from one side to the other. The potatoes are then pressed by the Scotch into the blades, which reduce the potatoes into matchstick pieces.
Implementation. Testing and troubleshooting session to ensure its functionality and efficiency of the machine. The sample are peeled potatoes. After taking reading, calculating total sample reading and its total reading will be give the mean. The mean reading will help for calculating results of the automated Scotch Yoke potato matchsticks cutting machine.